in today's session on the electromagnetic field. Today I am going to discuss some harder problem on capacitance. Myself Dr. Sayanthi Chatterjee, the faculty of Department of Electrical and Electronics Engineering of IARE College, Hyderabad. Today's problem is basically based on the GATE and for the different types of competitive exams. So we will discuss our first problem. A parallel plate capacitor has a plate area of 0.2 meter square and a separation of 5.5 millimeter. Find its capacitance when capacitor is charged to a potential 500 volts. Number 2, its charge, energy stored in it and force of attraction between the plates. So we will discuss by one. So, what is the capacitance? As in this question, if we study the question, there are some important keywords we have to understand. The parallel plate air capacitor. The first one is the parallel plate air capacitor, and next one is the plate area is 0.2 meter square and the distance is 5.5 mm. Find the capacitance when the capacitor has been given 500 volt. So these are our main key points of this problem. So when we will start the problems, we can write the capacitor plate area is equal to 0.2 meter square. Distance between them is 5.5 mm, and 5.5 mm is nothing but the 5.5 into 10 to the power minus 3 meter. Remember one thing, always the unit should be in the meter. So we know that this is an air plate, so epsilon is the epsilon naught, or the permittivity of the free space or vacuum, as it is an air capacitor, is equal to 8.854 into 10 to the power minus 12. So we know capacitor C is equal to epsilon A by D. So what is the value of epsilon? Is epsilon naught. 8.854 into 10 to the power minus 12 into 0.2 divided by 5.5 into 10 to the power minus 3, and the unit will be in the farad. So this is the simple problem. Calculate the capacitance of the capacitor when the capacitor in the charge to a potential difference 500 volt. So next is the what is the charge? According to the definition of the capacitor, we know what is a capacitance, the charge per unit potential area. So C is equal to Q by V. So what we have to calculate? Its charge is equal to C into V. What is V? V is given as 500 volt. So C value we can calculate from here. The C value we can calculate from here. So we know that C into V is 500 volt. So we will get the total value of the charge. We can get the total value of the charge. And what is the unit of the charge? The unit of the charge is in the coulomb. The unit of the charge is in the coulomb. Remember one thing, in the problems of the of any physics types problem, the unit and the is very important. So don't miss the unit. Please check the units very carefully. Question number C. What is the question number C? Energy stored in it. Energy stored in it. What is this energy stored? Energy stored is always half CV square. We know energy stored is half CV square. So C value we will get from here. V value we know 500 volt. So if we put the value half C into 500 square, we will get the energy stored in it. And I'm writing the energy stored is E. So, and what is the unit? Unit is always in the joule. So, this is our question number 3. Energy stored in it. Last question is the force of attraction between the plates. So energy stored is nothing but what is the energy stored? This is the little different problem. So up to 1, 2, 3, Up to 1 to 3 we can discuss any time, but the main challenge is the question number 4, force of attraction between the plates. What is the meaning of the force of attraction? So if there are two parallel plates, it will always feel some force. So we can write that force into displacement. We know force into displacement is equal to, what is this? This is actually the work done. And what is work done? This is the work done. So work done is always is equal to energy stored. So force into displacement is equal to work done of the is equal to the energy stored. So force value we have to calculate. Displacement means the plates will try to cover the distance between them. And what is the distance between them? 5.5 into 10 to the power minus 3 is equal to half c v square. So if we solve this equation, C value we know, V value is given, force into displacement value is also given. So if we solve this equation, we can get the value of the force. So what is force? Force is equal to half CV squared by 5.5 into 10 to the power minus 3. And what is the unit? Unit is Newton. So this is the first three questions are simple. The fourth point has a glitch, and that force of attraction between the plates. So what we know, force is equal to displacement. Displacement is equal to work done, and we know work done is equal to energy stored. So force into displacement is equal to half Cv square. Next, we are moving to our next problem. A cylindrical capacitor is construction using two coaxial cables of the same length of 10 centimeter of radii 5 millimeter and 10 millimeter. Calculate the capacitance. So again, it is a cylindrical capacitance. And it has two coaxial cable. It has two coaxial cable. The A is the inner radius is equal to 5 mm. 5 into 10 to the power minus 3 m. What is B? B is the outer radius is equal to 10 mm is equal to 10 into 10 to the power minus 3. So what is the capacitance? The capacitance is 2 pi epsilon ln B by A. What is B? B is the radius of the outer surface. A is equal to radius of the inner surface. So if we put the value B, so we will get 2 pi epsilon by ln into B by A means log ln 2. And if we put the value, we can get the value of the capacitance. As nothing is told, so we will take epsilon is equal to epsilon naught. Sorry, epsilon L. And what is L? Length is equal to, what is the length? Length is equal to 10 centimeter. 10 centimeter means 0.1 meter. So if we go for the second case, another capacitance of the same length means the second case L is equal to 10 centimeter, and the with the cylinder radii 8 millimeter and 16 millimeter. So radii, inner radii is 8 millimeter, and the outer radii B is equal to 16 millimeter. B is equal to 16 millimeter. So again, B by A is equal to nothing but the 2. So here also 2 L is same. So we will get in the both case, the capacitance value will be same. And what is the value? The value is 2 pi epsilon L by Ln2. So this is our problem number 2. It is about a coaxial cable. So if we can solve the coaxial cable like this. Now we will discuss about the problem number 3. What is the problem number 3? Problem number 3 tells two parallel plate condenser. Condenser is nothing but the capacitor A and B having the capacities of 2 microfarad and 10 microfarad are charged separately to the same potential 200 volt. If the positive plate of A is connected to the negative plate of B and the negative plate of A is connected to the positive plate of B, calculate the equivalent capacitance of the common voltage combination of the A and B and find the loss in electrical energy in the condenser. So first we will take that the let CA and CB. This is our question part actually. So let we have the two capacitance CA and CB which are connected with the condenser A and B. So what is the initial charge? We know that the Q is equal to Q by V is equal to C. So what is Q? Q is equal to V into C. For the first condenser, A condenser, it is 2 microfarad. So what is C1? CA is equal to 2 microfarad is equal to 2 into 10 to the power minus 6 farad. What is V? V for the both case is equal to 200 volt. So what is the total charge? Q is equal to V into C. 200 into 2 into 10 to the power minus 6, and we are getting the value 4 into 10 to the power minus 4 coulomb. Now we will move to the second case. What is the value of the CB? CB value is again given as the 10 microfarad. 10 microfarad. So what is the charge? 10 into 10 to the power minus 6 into 200. So it is 2 into 10 to the power minus 3 coulomb. Now, what is the charge? Now, if we want to draw this two parallel plate capacitor, this is the main point or main USP of this problem. We have to draw the connection of the capacitors perfectly. So I am using this. So this is one capacitor A. This is one capacitor. I am using the another color so that it is easy to understand. It is another capacitor B. This is positive. This is negative. This is positive. This is negative. So what is the charge on the first plate? It is the first plate. So we are giving the name A1, A2. Again, what is the name of these two? The name is A3 and A4. Okay, so A1, what is the connection they told? The positive plate connector is connected. A is connected to the negative plate of B. So A1 is connected to the negative plate of A. This is the B3. It is the B4. Or we can write B1. B2, then it is easy to understand. So the positive of A1 is connected to the B2 and the negative positive of B2, the positive plate of A is connected to the negative plate of B and the negative plate of A is connected to the positive plate of A. So this is the new connection. So this is the two capacitors, blue and green. A is connected to the B2 and A2 is connected to the B1. This is the capacitor plate. This is the capacitor plate. Now, what is the charge in A1? We told that the charge is 4 into 10 to the power minus 4. So, A1 charge is 4 into 10 to the power minus 4 coulomb in the positive plate. So in the positive plate, then similarly for the induced voltage, it should have the -4 into 10 to the power -4 coulomb. If we go for the B1, in the B1, positive plate has the charge of 2 into 10 to the power -3 coulomb. So negative will be must be 2 into 10 to the power -3 coulomb. So if we add A1 to B2, what is the total charge of this? Now these capacitors are looking like A1, B2, A1 connected with B2, A1, B2, A1 and B2 are connected, A1, B2, and another plate is now A2 and B1. So this is our new capacitor, two parallel plate capacitor. First one is a combination of A1, B2 and it is B1, A2. So what is the charge? A1 plus B2, A1 plus B2. So we are getting the charge. A1 charge is 4 into 10 to the power -4 coulomb. B2 charge is -2 into 10 to the power -3. So if we calculate it, we can get -1.6 into 10 to the power -3. What is the charge into Q2? Q2 charge will be -4 into 10. A2 charge is -4 into 10 to the power -4 plus B1. B1 is 2 into 10 to the power -3 coulomb. So we are getting as 1.6 into 10 to the power -3 coulomb. So we got already these two charge. So we can see A1, B2 has the negative charge and B1, A2 has the positive charge. So we can think that the overall are in a parallel combination. So we can write CA plus CB, CA as if CA plus CB, calculate the equivalent capacitance. So we have to calculate the equivalent capacitance here. Positive to positive, negative to negative means they are in the parallel combination. So we can write what is the total capacitance. Total capacitance are in CA plus CB. CA plus CB means we are getting the overall capacitance. Overall capacitance is 12 because 10 plus 2 is equal to 12 farad or 12 microfarad. 12 into 10 to the power -6. How? CA value is given as 2 microfarad. F value is given 10 microfarad. So if we add these two, we will get the 12 microfarad. What is the charge for this? The charge Q. What is the total charge? Charge is 1.6 into 10 to the power -3. 1.6 into 10 to the power -3. So Q is equal to C by V. So V is equal to Q by C. Q value we got. C value is 12 into 10 to the power -6. So if we put the value, we can get the value of the capacitor. What is the second question? Find the loss. So what is the electrical energy loss? Half CV square. So as I told, now what is the lot? E is equal to 12 CA into V2 plus 12 CB into V2. So what is the previously? What is the energy? In the previous case, energy is not 12, half, sorry. Half CA V2 plus half CB into V2. But what is the new condition? New condition is E is equal to half CB2. Half CB2 is equal to 0.106 joule. Where C is the, what is C now? C is equal to 1.2 into 10 to the power -6. What is the potential? We have given the potential. So potential is 12. What is the potential? Potential is 200 volt. So if we put the value, we can get, this is the case 1 when both are not connected. This is the case 2 when both are connected. So what is the loss of energy? Loss of energy is equal to EI minus E is equal to -1.33 joule. So what is the main thing? CA and CB both are connected in the parallel. First we have to take the parallel combination, then we have to solve the problem. So this is our problem number 3. Now we are moving to our problem number 4. Find the capacitance of a 4-plate capacitors of cross-sectional area A meter square separated by a distance D1, D2, D3. Find the space between them filled with the sigma 1, sigma 2, sigma 3 and permittivity of the sigma naught. So how to calculate this? The 4 parallel plate capacitors of a distance of D1, D2, D3. 1, 2, 3, 4. What is the distance between them? D1, D2, D3. Actually, it is a 3 parallel plate. The question is little different. It is the 3 parallel plate. So 3 are in the parallel combination. So what is the equivalent? We know for the 1 by CEQ is equal to 1 by C1 plus 1 by C2 plus 1 by C3. What is the C1? C1 is equal to epsilon 1 A, because all are A, by D1. What is C2? Epsilon 2 A by D2. What is C3? C3 is equal to epsilon 3 A by D3. So if we add these 3, we can get the C equivalent. So D1 epsilon 1 A plus D2 epsilon 2 A plus D3 epsilon 2 epsilon 3 A. So if I take 1 by A outside, D1 by epsilon 1 plus D2 by epsilon 2 plus D3 by epsilon 3 is equal to 1 by A epsilon 1, epsilon 2, epsilon 3. So it is epsilon 2, epsilon 3 D1 plus epsilon 2, epsilon 1, epsilon 3 D2 plus epsilon 1, epsilon 2 D3. So what is C equivalent? C equivalent is equal to A epsilon 1, epsilon 2, epsilon 3 divided by epsilon 2, epsilon 3 D1 plus epsilon 3, epsilon 1 D2 plus epsilon 3 2 epsilon 1 D3. This is our equivalent capacitance. Discuss the effects of the dielectric. Dielectric are non-conducting materials for the glass, mica, wood. So dielectric is a non-conducting material. So it is, for the example, is the glass, mica, wood. What happened when the space between the capacitor, what will be happen when the space between two plates of the capacitor is filled with the dielectric? Again, it was first discovered by Michael Faraday. Faraday discovered that if the space between the conductors of a capacitor is occupied a dielectric, the capacitance of the capacitor will be increased. So if it is a free space, capacitance will be decreased, but if it is full of the capacitance, the value of the capacitor will increase. If the dielectric completely fills with the conductors of the capacitor, the capacitance is increased by factor K, which is the characteristics of the dielectric. Dielectric constant for the equum of the is unity. Actually, relative permittivity is unity. Consider the capacitors of the capacitance. Charge is connecting to a battery, then the charge, if the Q naught is the charge of the capacitor, then C naught is equal to Q naught into V naught, and C naught is equal to epsilon A by D. So this is the effect of the capacitance of a capacitor. Next, deduce the capacitance if a spherical capacitor when the inner sphere is earthen. So what is the cause? So if a positive charge Q coulomb is given to the outer sphere B, it will distribute itself for the both inner and outer. What will happen? If a positive charge Q coulomb is given to an outer sphere B, it will distribute itself over both in inner and outer surface. So if this is a sphere, if this is a concentric sphere, if we give the charge on it, it will always and the inner sphere is earthen, not the outer sphere. The inner sphere is grounded. What will happen? The charge will be distributed on the surface. As we know, the general tendency of the charge is to lie on the surface of the conductor. So let's the charge Q1 and Q2 coulombs be at the total charges Q1 into Q2. The charge Q1 is in the inner surface of the outer sphere. If we are giving the Q1 charge in the inner surface of the outer sphere, will induce the opposite voltage in the outer surface of the inner sphere. If we give the charge in the inner surface of the outer sphere, it will induce some charge on the outer surface inside the sphere. So what will happen if we give the plus Q1 charge here? It will induce the minus Q1 charge on the outer surface of the A, and plus Q1 charge on the inner surface of the sphere A. So it is A, this is B. So what will happen? This charge will go to the ground. Now there are two capacitors. We can think there are two capacitors connected in parallel. So what will happen? One capacitor consists of the outer surface of a sphere B and earth having the capacitance C1 4 pi epsilon naught B farads. And the second capacitor consists of the outer surface of the B and the outer surface of the inner sphere have a capacitance C2 4 pi epsilon B A into B by A. So this is a combination of the two capacitors. Find the equivalent capacitance and charge on 5 microfarad in the circuit. So find the first equivalent capacitance. How to calculate the equivalent capacitance? You can see 2 microfarad and 5 microfarad are in parallel. So if it is, what is the equivalent for these two? If we want to draw it, it will be 3 microfarad, and parallel combination means simple addition. This is the 7 microfarad. Then next one is the 4 microfarad. I am drawing only the capacitance portion. Now 3 and 7 are in parallel. So what is the equivalent for these two? It is 21 by 10. So we are getting here 2.1 microfarad, because AB by B plus A. AB 21 by B plus A. 21 by 7 microfarad. So 2.1 microfarad. And again this is 4 microfarad. These two are also in the parallel. So what is the equivalent? The equivalent is 4 plus 2.1 means 6 microfarad. So we can get the first answer. Find the equivalent capacitance of the this charge. Next part is the find the capacitor in the find the charge on the 5 microfarad capacitor. So if we can see what is the charge in the 5 microfarad capacitor, how to get this value? How to get this value? The equivalent of this line is 2.1 microfarad. It is a parallel combination. This line and this line are in the parallel combination. So voltage across AB is equal to again 6 volt. So what is the total charge? The total charge is the 6 microfarad into the 6 microfarad into what is the voltage? The voltage is 6 volt. Sorry, voltage is 6 volt into the capacitance. Q is equal to C into V. Q equals to C into V. So what is the value of C? C value we got 2.1. So what is the total charge? Total charge is 12.6 coulomb. Now the total charge will be divided here and it will be divided into the two parallel paths. So what is the charge distribution of this two? We have to calculate what is the charge distribution of this two. First we have to calculate, we know the total charge Q is equal to 12.6 coulomb. So what is the charge across the 3 microcoulomb? How to get this? This total root is total is the 6 volt. So what is the voltage across the 3 microfarad? Total charge is 12.6 by 3 microfarad. If we calculate the voltage is 4.2. This is microcoulomb. So this is the 4.2 volt. So voltage across the 3 microfarad is 4.2 volt. So what is the charge between, what is the voltage across this? If the total voltage is 6 volt, the voltage across this is V parallel. Voltage across this is 6 minus 4.2 volt. So what is the volt? Volt is 1.8 volt. 1.8 volt. So if the voltage across this is 1.8 volt, what is the charge across the 5 microfarad? So Q at 5 is 1.5 into the capacitance. What is the capacitance of this? 5 microfarad. So it is coming at 9 microcoulomb. So what are the steps? First step is these 3 lines are in parallel. So we can calculate. So the voltage across this AB is 6 volt. What we can do here? We know the equivalent resistance. So in the equivalent resistance, what is the equivalent resistance? 2.1 microfarad. So first we can calculate the total charge. The total charge is the 12.6 microcoulomb. Now if we get the microcoulomb voltage, it is over the total capacitance. It is divided into the over the total capacitance. So it must be within this. So we know the capacitance. So what is the voltage? Voltage is equal to charge by the capacitance. Charge by the capacitance. We got the voltage drop across the capacitor. So if the total voltage is 6 volt, it is 1.8 volt. So 4.2 volt. So it must be 1.8 volt. It must be 1.8 volt. So if we get the value 1.8 volt and we know the microcoulomb, then we can get the charge 9 microcoulomb. We can check also what is the value of Q. What is the value of Q6? The Q6 value will be 1.8 volt into 2 is equal to 3.6 microcoulomb. And if we add 9 microcoulomb and 3.6 microcoulomb, again we are getting the value 12.6 microcoulomb. So you can check the problem like this. A parallel plate capacitor has the following dimensions. Distance between them is 10 cm. Area of each plate is 2 meter square. Charge on the plate is 8.85 into 10 to the power minus 8 coulomb. Calculate the capacitance of the capacitor. So what is the capacitance? Epsilon A by D. What is the value of epsilon? 8.854 into 10 to the power minus 12 into A is 2 meters square by D. D value is given as the 10 centimeter. 10 centimeter means 10 into 10 to the power minus 2 meter. So this coulomb. So what is the value we are getting here? 8.854 into 2 into 10 to the power minus 13 minus 2. 13 minus 2 means minus 11 coulomb. Or we can write, this is the value. So what is the energy stored in the capacitor? First we have to calculate the V. How to calculate the V? We can solve this problem in two ways. So we can solve the problem in the method 1. What is the method 1 told? Method 1 told the energy stored in the capacitors, we can use the formula Q square by 2C. What is the value of Q? 8.85 into 10 to the power minus 8 square by 2 into C. 8.854 into 2 into 10 to the power minus 11. So we can use this formula, or method 2 we can use. What is the voltage? Voltage is equal to Q by C. Q value we know, 8.85 into 10 to the power minus 2. What is the value of C? The value of C is 8.854 into 10 to the power minus 12. We got the value of V. So if we got the value of C and V, so what is the total charge? Half C into V square. V is 100 volt. V is 100 volt. C value we will get. So if we put the value, we can get the energy, and always the energy will be in the joule. Now I am moving to the problem of 9. Consider a system of capacitor where two parallel plate air capacitors of each capacitance C are connected in series with a battery of EMF Xi. Now one of the capacitor is filled uniformly with the dielectric constant K. What happened to the field strength of the capacitor, and what will be the change in the electric field strength? First, we have to calculate the charge and voltage of each capacitor. Given this in the problem, given the both capacitance is the C. So since both capacitors are connected in series combination, so the charge for the both capacitors would be the same. As we told you before also, if both capacitors are connected in series, charge will be same. So the voltage across this Xi is equal to this voltage plus this voltage Xi. The potential difference V across each capacitor is Xi. What is the Xi? Xi is the voltage. V plus V. It is divided into two parts, so Xi by 2. So what is the charge on each capacitor? Voltage across each capacitor is Xi by 2. So charge is equal to C Xi by 2 in the absence of the dielectric. Now we are connecting a dielectric here. So one capacitance will be changed into the Kc. So what is this? This is in the series connection. So 1 by C dash is equal to 1 by Kc plus 1 by C. So what is the equivalent capacitance? C dash is equal to Kc plus 1 plus K. So this is a gate problem. So what is the problem? We are two capacitance of equivalent charge are connected to the charge in Xi. So what is the Xi? Xi is equal to 2 voltage V plus V, or V is equal to Xi by 2. So what is the charge? Charge is equal to C into V. So what is V? V is equal to Xi by 2. This is when both are without capacitance. Now, if we connect one capacitance, then 1 by C dash is equal to 1 by Kc plus 1 by C. So, C dash is equal to Kc by 1 plus K. Now, we are discussed about the problem number 10. A parallel plate capacitor with mica having the epsilon R is equal to 5 is connected to the 10 volt battery. The area of the parallel plate is 6 meters square and the distance is 6 millimeter. Find the capacitance and stored charge. So first part is very easy. C is equal to epsilon A by D. Epsilon value we know 8.854 into 10 to the power minus 12. Then A is given as the 6 meters square by D is given as the 6 millimeter. 6 millimeter means 6 into 10 to the power minus 3. So we got the value 8.854 into 10 to the power minus 9 farad. Next is the what is the energy? Energy stored. We have to calculate the stored charge. Charge is equal to what is the charge? The charge Q is equal to C into V. What is C? C value we got 8.854 into 10 to the power minus 9. V is equal to 10 volt. So we are getting 8.854 into 10 to the power minus 8 coulomb. So this is the first part. First part is very easy. We have to understand the second part. What is the second part? After the capacitor is fully charged, the battery is disconnected. So we can disconnect the battery and the dielectric is removed carefully. Calculate the new values of capacitance, stored energy and charge. So now the capacitance don't have it has no charge. Now what will be the capacitance? So C is equal to now epsilon naught A by D. So what is the second part? So what is the C naught? C naught is equal to what is the C naught? C naught is equal to C by epsilon naught A by D. What is the epsilon R was there previously? Previously epsilon R was 5. So what is the capacitance? C by epsilon naught, we are getting the value 8.85 into 10 to the power 9. So I will do this problem once again. So first one is the what is the capacitors? C is equal to actually epsilon naught. First A problem. In the A problem epsilon naught, epsilon R because it is mica. So what is epsilon naught? Epsilon R A by D. 8.854 into epsilon R is equal to 10 minus 5 by A. Sorry. 10 minus 12 by A. A is 6 by 6 into 10 to the power minus 3. But epsilon R value is 5. So if we solve it, we are getting the 44 nano, almost 44 nanofarad. This is the first part of the problem. So what is the stored charge? Stored charge Q is equal to V into C, 44 nanofarad into 10 volt. So for 440 nano coulomb. For the second case, as I discussed earlier also, the mica has been removed completely. So it is epsilon naught into A by D and we are getting 8.85 nanofarad. Now, so first part is okay. Now we have to calculate the stored charge. As the system, as the there is no battery and no dielectric, so charge will be same. So Q will be again 440 nanocoulomb. Now stored energy. Now for the first case, stored energy is equal to half CV square. We can calculate half. C value we know 44. What is the V square? V square means 100. 10 square 100. So we can get 2200 nanojoule. But what will happen if we, in the second case, there is no battery. So we have to use the energy formula. Energy is equal to Q squared by 2C. So 440 squared by 2C is equal to now 8.85. So if we solve this, we will get the new energy. And what is the, it is the second case. This is the problem number 10. So today I have discussed some harder problem. Now I will this is the all are for the GATE and different type of exam purpose. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.